Welcome to At Issue. As always, thank you for joining us. My name is H. Wayne Wilson, and I want to remind you that when you're reading a publication, it may very well have been printed with soy-based ink. If you pour a light dressing on your salad, it may very well have a product called Otrim in it or some other products. And then let's take a look at how we deal with diapers. Super Slurper can absorb 100 times its weight in water. That's very useful when you're talking about diapers and when you're talking about filters, fuel filters and oil filters. And all of that came out of the Ag Lab on University Street in Peoria, Illinois. And the Ag Lab is celebrating its 75th anniversary. And we want to look at the past successes and current research as they celebrate 75 years. And to do that, we've invited Dr. Joseph Rich to be with us. Dr. Rich is a research leader at the Ag Lab. Thank you for being with us.
Thank you for having me.
And Dr. Stephen Peterson is here. He's a research microbiologist.
Pleasure.
You deal with little things.
Yeah, very.
Okay. All of you probably deal with little things. Dr. Gregory Cote is here. He's a research chemist. Thank you for joining us.
Thank you.
And the center director is Dr. Paul Sebesta. Thank you for being with us, Dr. Sebesta.
Good to be with you, H.
And I mentioned the 75-year birthday. So it started in 1940.
1940.
Now, one of 4 regional research centers.
In 1938, Congress allocated $4 million to the Secretary of Agriculture to build 4 regional research centers. They were located on the East Coast, the West Coast, the Gulf Coast, and here in the Midwest. So we were one of 4. They were all constructed the same, they were designed the same, and they were opened at about the same time.
And if I understand it correctly, East Coast was Philadelphia, South was New Orleans, and then the San Francisco Bay Area was the West Coast. And then, so we have Philly, New Orleans, San Francisco, Peoria. Why Peoria?
Peoria Lab was set up as a fermentation center to go along with the whiskey business that was already here. The timing was wonderful because penicillin had just been tested out and proven to be effective in England. But in England, they could not build new factories to make penicillin because of the Blitz and the U-boat blockade of the island. And so when penicillin was brought to the U.S., it was redirected to us as the best possible place to study how to make meaningful amounts of penicillin.
And we're going to talk about that penicillin because it was not, the growth of it was accidental in discovering how it could be replicated real quickly. So we'll talk about that in just a moment, but okay. I want to go back to the history of the unit itself. Soybeans, everyone knows that there's a lot of soybean research going on at the Ag Lab, but that really wasn't the case at the start, was it?
No. When the lab started, the focus, each regional lab had a different commodity crop focus, and our lab was focused on corn and wheat. And soybeans, 100 years ago, was a relatively minor forage crop. And the work at the lab on developing uses for soybeans and the oils that come out of soybeans have led to a significant expansion in the utility of soybeans. And today you drive around the middle part of Illinois and we see about half corn and half beans, in part because of the research that was done in our lab.
We're going to be talking about new research. We're going to be talking about past successes such as penicillin and sometimes the accidental discoveries. I want to talk about root beer. Just who wants to talk about root beer and what that has to do? Everyone's out there going, H, come on.
Well, it is another so-called accidental discovery that came from root beer, brought to the labs in the late 1940s by a local root beer bottler, and it had turned slimy and spoiled, and he brought it to the lab because he knew that fermentation research went on here. And people looked at it and said, oh, it's a bacterium that produces this slime. It might be interesting for something. We'll put it on a shelf for now. And a few years later, they started a project looking for what's called a blood plasma expander. The Swedes had started to look at something similar for blood plasma expanders. They started a project here surveying all sorts of different microbes that make this slime that thickens water. And they found that the one that had been brought in a few years ago from this spoiled root beer happened to make the most of this material called dextran, and it turned out to be the best for a product that was eventually commercialized as a blood plasma expander. And you'll still find this in emergency rooms across the country and across the world.
And it was most useful in the Korean War, if I recall.
There was a lot of interest in the early 1950s because of the threat of nuclear holocaust and the need to build up blood plasma and blood plasma substitutes for treating shock on a large scale.
There were other accidental discoveries. One of those came from a tree stump, is that right? Am I understanding that correctly?
Yeah, there's a material called xanthan gum that was discovered here in the labs in Peoria. And it's made by another bacterium that was isolated from a rotten tree stump in the backyard of one of the scientists who was studying it. And when people say accidental discoveries, it really shouldn't be looked at as an accident. There's one of my favorite sayings is serendipity favors the prepared mind. So people may have observed these things at times in the past, the same as they did with penicillin, and just thrown it out. If you're thinking about what it could be good for, then you've already prepared your mind for looking at using these so-called accidental discoveries for something that may be of interest.
And I can give a more recent example of that in this product that one of our scientists identified. It's not a product, it's a substance that one of our scientists identified. He was out in his backyard trimming some bushes in his backyard, and as most of us do when we trim stuff, we throw it in a pile. And so he threw it in a pile, but he noticed that a substance was coming out of the trimmed end of the branch. So he looked at that and he thought, well, this is kind of interesting. So he took a sample of it. He teamed up with the chemist at the Ag Lab, and this has just happened recently. Chemist at the Ag Lab, they did some evaluations, and they found that this may, we're still doing the research, but it may be a suitable substitute for gum arabic. Gum arabic is used in a whole host of products, from soft drinks to cosmetics to pharmaceuticals. And gum arabic is sourced from some politically areas that are in political turmoil and social turmoil now, and that's where 80% of the gum arabic comes from, and that can cause spikes in the product. Well, this could be a locally sourced, U.S. source of gum arabic, and that would be a tremendous boon to the country.
And where are we in regard to?
We are in the early stages of this research, and we're still evaluating that substance. So yes.
While we're talking about that, you're in the early parts of the research, but as you go along and you decide that, hey, this does have commercial value, how does that work? Do you reach out to somebody? Do they reach to you to do the commercial aspect of this?
I think it happens both of those ways. Frequently, we are presenting our work, be it in publication in the scientific literature or speaking at conferences or to the general public, and people can hear about those types of products in that way. But other times, companies or academic researchers will interact with them at meetings, or they'll come to our lab and we'll learn about their research needs. And it's that relationship that you build with other researchers that opens the doors to coming up with new applications for these accidental, if you will, discoveries that really allow us to build on that serendipity.
There's that word again, accidental. You don't like to use it, but it's real.
The accidents can happen. It's what you do when you have the accident. If you fall down and happen to pick something valuable up when you get up, then it's worth falling down once in a while.
Now, I want to talk a little bit about some of the new research that's going on there. In particular, the green aspects to the new research. Can you give me some examples of what you're looking at in terms of the green, meaning environmentally friendly?
A good example I can use is a disease insect complex that is plaguing the avocado industry in California and Florida. There's a beetle that's called the ambrosia beetle that is feeding off of avocado trees. It has a wide host range, a number of trees. One of them happens to also be a laurel tree that's in the Everglades, and so the laurel trees could be at risk. So we have a management unit there, a research unit there within the center that is focusing on crop bioprotection. How do we use some of the microbes that we have in our extensive culture collection to control insects and disease pests of crops and important plants. So we are investigating this. We're making progress in this particular instance, and we are now in field trials in California and in Florida with the local universities there.
And the goal, the bottom line is the
Bottom line is to control the ambrosia beetle and the fungus that the ambrosia beetle injects into the plant to kills the plant.
so the beetle will be gone.
The beetle will be gone, one way or the other. The beetle, if the research pans out, but we're still, once again, in the early stages of this research.
And the reason I bring that up is so often we see that, oh, here's a solution. We'll bring in this invasive species and it'll kill this other thing, or we'll kill off this animal or this creature. And so that's part of the research is to see, is there an impact if we do?
When we do all these things, there's an environmental impact that we look at, absolutely. So, and there's a specific process that we have to go through to do these field trials that evaluates that aspect of the trial.
There's probably many people. Oh, go ahead.
You know, to follow up on your question about the green aspect of our research, I think that we have a significant effort on developing new chemicals, new products, new biomaterials that can be made from corn or things that farmers can grow around here and across the country that will lead to products that can replace those products that we already source from petroleum, for instance. So they'll have an environmental benefit. We won't have a reliance as heavily on petroleum based products, and it'll also lead to products that help benefit the environment.
Let's talk about petroleum. I found it interesting in doing my homework, and most of that homework was provided by you, but
Glad we can help.
nonetheless, 75% of a barrel of oil is used for transportation needs in one capacity
The
or another.
liquid transportation fuels make up about 75% of a barrel of oil. About 3 to 5% of the barrel of oil goes into what's known as petrochemicals, which are all the building blocks for plastics and a lot of the products that we lay our hands on a daily basis. But those two different pots, a 75% slice of the pie and a 3 to 5% slice of the pie, generate roughly the same revenue for the petroleum industry.
So they're not making, the oil companies are not making, relatively speaking, not making as much money on selling diesel fuel, gasoline, as they are on those other products like plastics.
Right. The transportation fuels are the highest volume and lowest margin product that we can really reference to. There's a much higher margin and lower volume on a lot of the chemical usage.
So that brings to mind the question, now with fracking, et cetera, we're seeing a more resource for oil, for natural gas, et cetera. So we've extended out that time frame, who knows what the time frame is, with when we will run out of oil. But it is a finite fuel. And so what is the Ag Lab doing with regard to research on alternative fuels?
I'll let Joe speak to that a lot because that's his research focus. But I will say that we have, of the research projects that we have going on at the Ag Lab, roughly 50% of those are focused on renewable energy, biofuels, renewable plastics. The other 50% is on some of the green technologies, the food safety, and the functional food aspect.
So regarding fuels, we look at it really as a biorefining kind of research program. So it's not limited to just generating liquid fuels. Going back to that petroleum-based model, that petroleum refinery is fuels and chemicals and some other energy-related products. But the current biofuel industry is really the production of ethanol, which is very common here in central Illinois, and the co-production of animal feed. And that refining industry, to be even more effective and more impactful going into the future, needs a large diversity of products, just like the petroleum refineries have, that will lead to a more economically viable biorefining industry. What are we doing? We're working on developing new products that could be those other things that are made along with making biofuels. We work with ethanol producers to help them improve how they make ethanol, but we're also working on how to convert other plant materials, not just corn, but the stalks that are left in the field or other types of grasses that could be grown in other parts of the country. Switchgrass.
And
would be a
pennycress is another
good
one, which is a
example.
weed.
Right, right. And how can we convert those into useful liquid transportation fuels?
Let me turn to the question of carbohydrates. A lot of success has come out of carbohydrates. What is a carbohydrate?
Carbohydrate is a compound that comes from nature, made by plants, that has a specific ratio of carbon and oxygen and hydrogen. Generally, they're considered sugars or things that are made from sugars. So it could be anything from high fructose corn syrup to table sugar to some of the things that are made from those, like starch or cellulose, like in paper or cotton.
So high fructose corn syrup came out of the Ag Lab here in Peoria?
Some of the technological developments that made high fructose corn syrup possible came out of the labs. Some of the enzyme biotechnology advances came out of the labs here in the 1950s, actually.
And you mentioned dextran earlier, the
Right.
expander of blood plasma.
Right, dextran is a carbohydrate. It's a slime that's actually made from sugar. And we've done some research on sugar over the years. A lot of people don't realize about half of our country's sugar comes from the Great Plains and Upper Midwest, from sugar beets, rather than from the sugar cane that's grown along in the Gulf region. So we do some work on turning sugar into more valuable products like dextran. More recently, we've developed a way to turn sugar and corn syrup into something that we call sucromalt. And this was developed in collaboration with a private company as a low glycemic sweetener. That is a sweetener that doesn't cause very sharp, intense increases in blood sugar in people with diabetes.
And then I mentioned Super Slurper at the top of the show, used in filters and
Right,
and
it's
diapers.
a starch where the molecules are cross-linked or attached so that they swell up and absorb water rather than dissolving in water.
The members of the audience are probably sitting out there saying, H, come on, let's talk about the famous one, the first big success out of the Ag Lab, penicillin. It's another accidental discovery. if
Another
I may use that.
serendipitous discovery of tremendous impact that was discovered, put on the shelf for a while, and near the beginning of World War II, it was taken up again by a research group at Oxford University in England. They did proof of concept. They showed that penicillin wasn't toxic, that it also would cure certain bacterial diseases. But after proof of concept, they were unable to develop it further because the Germans were bombing England. It pretty much destroyed it. You couldn't build a new factory. So the project came to the United States and was referred to the Northern Regional Research Lab here in Peoria, where we were set up to do the kind of fermentation work that would be needed to make penicillin in big amounts. And one of the first scientists to work on it successfully was Andrew Moyers. He was a nutritionist, and he tested out different nutrients that would make the fungus happy and make it pump out a lot of penicillin. And in a matter of 3 months, he was able to improve the production of penicillin by 100 times. Truly amazing. The amount being made before that was so minuscule that it took dozens of people weeks to make one therapeutic dose.
But 100 times,
All of a sudden, it's starting to look possible that this could be a drug that's actually used. The one great hurdle that still remained was Fleming's penicillin had to grow in a shallow pan and couldn't be agitated. And pharmaceutical companies wanted to grow it in 10,000-gallon vats with impellers running through to stir everything up. And that required a worldwide search for a new strain of penicillin-producing mold. It was found, strangely enough, because it was a worldwide search, it was found on a cantaloupe that was donated to the lab from a Peoria housewife whose name was not recorded. That strain was making nearly 100 times Fleming's. It could be grown in a submerged tank, and through selective mutation with ultraviolet light, with X-rays, with gamma radiation, in a matter of maybe 6 months, it had gone from making 100 times Fleming's strain to making 1,000 times, and it would make it in these 10,000 gallon vats. D-Day was approaching, was about 4 or 5 months off, and so this strain was released to the pharmaceutical industry, and that's how we got all of the penicillin, not only for military needs, but for curing all kinds of diseases and infections in the civilian population.
So it was ready for D-Day?
Absolutely. 20 million doses a month. I mean, it went off like crazy once we got the strains.
So if you look, so a lot of the discoveries from the Ag Lab have basis in a wartime effort. So the penicillin was based in the wartime effort. The Dextran was based in a wartime effort to support the Korean War.
Let me turn to some of the new research that's going on with lubricants, anti-corrosive, things of that nature.
We have several units there that are focusing on that specific area. We've got a nice anti-corrosive that helps in that area. We've got some motor oil lubricants that we're working with companies on getting those into the market. They're evaluating them now. One of the things that we have at the lab that a lot of other research facilities don't have is a pilot plant. So we can make these great discoveries at the bench level, the little small little volumes of the chemicals. And when you start talking about commercialization efforts, the first question that the business people have is, can you scale that technology? And so we actually have a facility there within our building that we can scale up that technologies to larger quantities and give those quantities out to test for economic concept.
And sometimes it spins off into a new company like ZooChem at the Innovation Center.
Mm-hmm.
Right, that company, still a small company, focused on making new carbohydrates like Greg was describing earlier, formed and initially did their research in our lab. And now they're a little bit bigger and working out of the Innovation Center and continuing on.
And ZooChem means what?
It's from the German words for sugar chemistry. And they do mostly work on sugars, carbohydrates.
We just have a couple of minutes remaining, and I would like to ask if there's some way to explain the impact, and I mean research, penicillin, Otrim, et cetera, but what's the impact on Central Illinois? I mean, we talked at the top of the show about Philadelphia has a research center, San Francisco, New Orleans, Peoria. We were fortunate to attract this. What kind of impact are we talking about?
Well, to me, that's hard to really measure because we have impact in so many different ways. The impact of being a large employer here with the salaries and income that flows through the economy, the impact of the smallest ZooChems that start up and their potential for the future, and the impact of bringing in visiting scientists from around the world that stay here. So we have a lot of impact in that particular area.
I think that the research that we do also leads to products that benefit the farmer who's growing crops, the companies that are converting those crops into new products like are developed in our lab, and then they benefit consumers that are using those products, buying them at the local grocery store.
And if we could talk a little bit about pennycress, because that's a very good example, because pennycress, as we mentioned earlier, is a weed. It's a winter annual weed, so it's seeded in the fall, and then it overwinters, and then it is harvested in the spring before soybeans are planted or corn is planted. That gives the local farmers here in the local community an additional income because it's using their land at a time when they don't grow corn and soybeans. So that has a significant economic impact as well.
We mentioned that it's the 75th anniversary of this particular, in fact, all 4 regional labs. But there is going to be an open house at the center.
Yes, there'll be an open house at the center, and it will be Friday and Saturday, October 9th and 10th. On Friday, we're open from 10. There will be guided tours that will be from 10 o'clock till 4:30 in the afternoon. On Saturday, we're open from 9 to 5:30. And tickets are available. You'll have to have a ticket to get in. Tickets are available. They're free of charge. And the best place for the people here in Peoria to get tickets is at the Riverfront Museum.
downtown Peoria, Riverfront Museum. I had a chance, I got a preview of the tour.
Yeah.
And there's a lot of old equipment that's not that old, but it sure looks old. The progress that you've made at the Ag Lab is phenomenal. I want to say thank you to all four of you for sharing the experience. And let's hope another 75 years has as many successes as you've had in the past 75 years.
Thank you.
Let me say thank you to Dr. Joseph Rich, a research leader at the Ag Lab, and to Dr. Stephen Peterson, the research microbiologist, Dr. Gregory Cote, a research chemist at the lab. Dr. Stephen Peterson is the research microbiologist, and Dr. Paul Sebesta is the center director. Thank you to all four of you for joining me on At Issue. We'll be back next time with another edition of At Issue. We're going to be talking about emotional recovery after a natural disaster. 18 to 24 months after the tornadoes in central Illinois, we're seeing more stress. We'll talk about how to solve that problem on the next At Issue.